This video is about dilution factors. First question is, what is a dilution factor? I've seen it defined as the factor by which the stock solution is diluted. The stock solution is the concentrated version. I've also seen it as the ratio of the aliquot to total volume. Aliquot is the reagent part or stock solution part. I've also seen it defined as the ratio of solute to solvent. But in all of these, the dilution factor has to do with the concentration and how much we lessen that concentration or change that concentration. A dilution factor of 115 means that the formulation is 1/15 the concentration it originally was. So how do we do this if we want to figure out what the original concentration was? What we do is we multiply the denominator of the dilution factor. So for example, if something has a concentration of 22 milligrams per milliliter at a dilution factor of 1 in 10, that means the original concentration is 10 times that strength. The original concentration would be 220 milligrams per milliliter. So this dilution factor is changing the concentration. Let's say that we want a dilution factor of 1 in 20, so something should be 1/20th the original strength, and we know that we need 40 milliliters of a working reagent. So that 40 milliliters is the aliquot or stock standard. How much diluent will we need to add? Well, the dilution factor is the concentration, which means it should be the stock standard part or the reagent or the medicine divided by the total volume, including the volume you're adding in with the reagent. In other words, 1/20th would equal 40, which is the stock standard, the amount of working reagent, divided by 40 plus some amount X. And this X is the diluent, which is the non-medicine or non-reactive part. I will leave solving this proportion to you, but this is just a proportion. We know how to solve proportions. What if a solution is currently at a dilution ratio of 1/3 and we dilute it again by doubling the volume without adding any more reagent? What would happen? So what I'm proposing here is that we start with a dilution factor of 1/3 and then we further dilute that by a dilution factor of 1/2. What is the final concentration? What is the final dilution ratio? So let's think this through. A dilution factor of 1/3 means that we have X milliliters of a reagent divided by the total. And this has to simplify down to a factor of 1/3. So X is the amount of the reagent, and then I need to add something in there to be the dilution factor. And again, I'm not worried about this second half, about diluting it again. I'm just thinking through this 1/3. The only way this is going to work is if this number right here is a 2x. And the reason I'm saying that is because x divided by x plus 2x is x over 3x, remembering there's an invisible coefficient of 1 in front of the x, and this simplifies out to be 1/3. So to achieve a dilution factor of 1/3, we need to have X amount of reagent and 2x amount diluent. So what I'm proposing is that we dilute this again by doubling the volume without adding any more reagent. I know that this down here is the volume. The denominator is our volume. Whoops. Pen. There we go. And so this volume is 3x. So if we double that, what we're doing is we're adding in one more 3x just to the denominator. So I don't know my dilution factor, but if I double the volume, this will turn into x, since we did not add any more reagent, plus 2x, so there's our original, and then plus another 3x because we doubled the volume. This works out to be 1x plus 2x plus 3x is 6x, which simplifies down to just 1/6. This would be our new dilution factor. Looking back at the problem, what we had is we had originally a dilution factor of 1/3, and then we diluted that by 1/2. Can you see how we would take 1/3, 1/2, and end up with 1/6? I hope so. Pause the video if you need to find out. But what we end up with is to find a new dilution factor, and we're doing something called serial dilution, which is not adding more milk to your cereal. It is diluting something that was already diluted. And the way it works is we can take all of those individual dilution factors and just multiply them together. Ta-da! Let me know if you have questions. Thank you.